Assalamu alaikum student, this video is related to the sample mean and variance. For the convenience, I have not taken a huge number of values. I have just taken 4 values in the population and taken that is total n is equals to 4 values, right? Now uh, I need to find out, let's say, the sample of size n2 with replacement and n2 without replacement. So first of all, for with replacement, how many samples I have? To find the numbers of samples, we have the formula n to the power n. This is the population n, this is the sample size, and for without we have a formula ncn. So in this case, if I apply 4 to the power 2, that means altogether 16 samples I should have, and over here altogether I must have 4c2, that gives me 6 samples, right? So yes, 6 samples. So let's see how to make the samples. The values are 2 4 6 8, right? So for the 16 samples I will have 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. Okay, the values are 2 4 6 8. So to make the sample of 2 is 2 with 2, 2 with 4, 2 with 6, 2 with 8. Then 4 with 2, 4 with 4, 4 with 6, 4 and 8. Then 6 2 6 4 6 6 6 8, and lastly is 6 8 2 8 4 8 6 8 8. Now when you are doing with replacement, remember the position doesn't matter. You take 2 4 4 2, both are taken, right? uh, yes, position matters when you're taking with replacement, means you have to take all the position in the words, right? But over here, let's see if I'm making for this one. So I need to make 6 samples. How I will make the 6 samples? It's 2 not with 2, because it's without replacement. I have taken out 2, so don't take, what are the population? 2 4 6 8, right? So 2 with 4, I cannot take 2 with 2. 2 with 4, 2 with 6, 2 with 8. Now 2 has done all the pairing. Throw away 2, come with 4 4 6 4 8, and then lastly 6 8. So when you are doing without replacement, 2 6, you cannot say that 2 6 is different from 6 2. 2 6 and 6 2 is like same, they have been taken. We cannot do the repeating case. It's a without repetition, it's a with repetition. Once you have done this, so to verify the two results, you need to just make the two columns. One is the mean and the other is the square of the mean. So mean is 2 plus 2 upon 2 is 2, 2 plus 4 upon 2 is 3, 2 plus 6 is 8, 8 upon 2 is 4, and this is 5. This is 3 4 5 6. Then this is 4 5 6 7. Then 8 9 10. It's 5 6 7 8. So just square it, just add them. This is the first column you will have. Then x square is 4. Why I'm doing the x square thing? Because I need to use it to prove the result for the standard deviation, or you can say the result for the variance is 4 9 16 25, 9 16 25 36, 16 25 36 49, 25 36 49 64. So you take the sum of this column as well. Same goes over here. Only the samples are different. The rest of the working you have to do the same. Mean of this and the square of the mean. Why I'm doing this? So ultimately you have to prove the two results. What are the two results? That from the population, you need to find out the population mean, which is 2 plus 4 plus 6 plus 8 divided by 4, right? And the population variance, which is let's say I'm representing like this, sigma square which is basically I have to apply the formula summation x square upon n minus summation x upon n whole square. So I will plug in this value. How can I find out summation x square? By squaring it. 2 square is 4, so the 16 plus 6 is 36 plus 8 is the 64, right? So just need to add them up. Whatever is the answer here, just plug in this answer over here. So this answer is 64 plus 36 plus 16 plus 4, it's 120, right? So 120 you have to put it over here, right? So it's 120 upon 4 minus mean. So let's find this mean is 10, 20. 20 upon 4 is 5. So this is 5 square. So it's 120 divided by 4 minus 5 5s are 25. So it's again the variance is also 5 and the standard deviation is definitely under root of 5. Okay, so I need to prove this result. How? For there are two things, with replacement, without. For with replacement, for with replacement, your result which need to be verified is that the population mean should be equal to the sample mean, and the other is that the population variance, if divided by n, then that should be equal to the sample variance. And how I will find out the sample variance? Sample variance could be find out by using these two columns, right, which you have made over here. This is the column of summation sum of x, this is the mean x bar, and then summation x bar square. So for that thing I will use summation x bar square upon its 16 in this case, because if I write a small n you might be confused. This small n is, in this case I'm using as a sample size, so I'm not writing small n, I'm just writing total number of values minus this value summation x bar value whole square, right? Summation x square upon n minus summation x upon n whole square. So when you plug in these values over here you will get this value. So this result you need to prove for the with replacement, and for without replacement what result you are going to prove is first as that mu will be equal to x bar, and the other one is population variance when divided by n and multiply by the n minus n upon n minus 1 correction factor, then this will be equal to the sample variance. And again for that also sample variance formula is this thing. All right, so you can try this, write in the comment if you have any issues, then I'm going to solve it for you people.